Hello, everyone. And on behalf of everybody here at InSum, I'd like to warmly welcome you to this 8th in a series of webinars based on InSum's ODTUG Kscope 18 presentations. This presentation is entitled Turning Apex into a Progressive Web App. Our presenter today is Vincent Morneau. Mr. Morneau is the front-end lead at InSum and has now more than 8 years of professional experience with information technologies. He is the creator of Apex Nitro, an open-source, user-friendly development tool designed to streamline front-end development in Oracle Apex. And as a result of the creation of Apex Nitro, Vincent was awarded Oracle Ace status at Kscope in 2017. Finally, watch for Vincent's further innovations in this coming year through his work with InSum Labs. And now, let's begin. Vincent, the floor is yours.
Hello, and welcome to this webinar on Progressive Web App with Oracle Apex. So first of all, what are you doing here, and who is this webinar for? If you are an Apex developer and want to learn about implementing Progressive Web App in Apex, then this webinar is for you. If you are managing a project, or if you can make decisions about the technological choices of an IT project, then this webinar is also for you. If you are simply curious and want to know more what a progressive web app is and what it can do, then this webinar is also for you. I'd like to start this session by making a statement. A lot of people see Apex as the best platform for creating business applications. But in 2018, I think Apex is ready to be the best platform for creating any kind of applications. And the only reason this is not a universal fact is because Apex still has to propagate to bigger and other markets. So this webinar is about exploring a market that Apex hasn't reached yet. And it is also a market that Apex is about to burst into. I'm really talking about the market of native mobile applications. My name is Vincent. I've been doing full-time Apex since 2010, and I'm currently the lead front-end for InSum Solutions. We've been doing consulting, application development, training for over 15 years. So if you need Apex firepower, please reach us. InSum is also sponsoring this webinar, and it produces many other webinars. If you are interested in free, high-quality content, you should check them out at insum.ca. I am also involved in the development of a few open-source projects, such as Apex Nitro or Material Apex. I especially love creating tools to increase developer productivity and share them to the community. You can follow me on my blog, Twitter, or GitHub at the handles here. Okay, so let's establish something clear. PWA stands for Progressive Web App, and it refers to a bucket of concepts aiming to close the gaps between a traditional web app and native mobile apps. PWA are not about one technology. They're about a set of modern web browser APIs that, if you put them together, make the case for a very compelling user experience that resembles a native app. I've always been a web developer. I love the openness of the web and the freedom it gives. I love the standards of the language it uses. I also love the fact that web apps can be released without involving user via system updates or anything. I also love the fact that web apps don't need a special license to develop on a platform like iOS. What I don't like is having to learn multiple languages to publish the same application on iOS and Android. I also don't like that we have to go through the Apple approval process to release a new version of our application on iOS. But there is no denial that native apps still have clear benefits over web apps. Given the choice, most people will choose a native app over a web app, and there are pretty good reasons for that. Let's use Twitter as an example. You can install Twitter from the App Store or Google Play, and then Twitter finds a way with their little bird icon directly to your home screen, and you can open the Twitter with muscle memory, basically. Twitter also launches in full screen, and you don't see any URL bar or any browser cluttered feature. The UI is dedicated to Twitter features only. Twitter sends you a notification when someone retweets you. It engages you to go back into the app over and over again all day long. Twitter still works offline. You can still write your tweet when you're offline. The tweet will be sent automatically when you get connectivity back. So no need to reopen the app and resend the tweet. Twitter can access native device features such as the camera, the GPS, and more. And there's actually probably more features than that that are more beneficial on a native mobile app. Until now, web apps were not able to do that. And the reality is that according to ComScore mobile app report, 87% of data consumption comes from native apps, leaving only 13% coming from web apps. So as an Apex developer myself, I look at this chart and I can't help but think that we're missing an important market share here. Progressive web apps can help us grab some of that market share back. So learning to turn Apex into a PWA really comes down to learning a small number of modern browser APIs. These APIs will allow your Apex application to match a native app experience. Making a PWA doesn't require the use of external or third-party libraries at all. In other words, everything I'll be showing today is pure JavaScript and pure Apex. Okay, so to close the gaps with native mobile apps, today I will cover the following concepts. Number one, app manifest. An app manifest is the configuration that allows your web app to be installed on the device. In most cases, PWA tend to be installed on mobile devices, but the app manifest actually allows you to install your PWA as a native desktop application as well. We will see how to reference the app manifest within Apex shortly in this webinar. Number two is service workers. A service worker is essentially JavaScript code that lives in the background of your application, meaning that a service worker can still operate when the browser is closed or when the phone is off. A service worker is kind of like the mastermind at the center of the PWA. It's the code that links everything together for a seamless native app experience. Then we'll look at the cache API. The way that we're going to enable offline usage is by caching resources. Browsers provide a cache API for storing resources. In the context of an Apex application, what we want to do is to cache something called the app shell, which means essentially the Apex pages, along with the necessary JavaScript and CSS and other files required to display Apex pages. Then we'll look at the Sync API, because offline usage is a great first step, but the true power only comes when you can continue using your features in your app when you're being offline. The Sync API will synchronize any pending request that you do when you're offline when the signal comes back. Then we'll look at the Notification API. The Notification API makes it possible to send a notification at any time. With this API, we can choose the notification icon or the vibration pattern. It also handles what to do when we click on the notification or when we dismiss the notification. In the context of Apex, a notification can be sent to all users of the application, or maybe a specific group of users, or even a single user. All right, so we will go in the implementation details for all of the previous features, but before we talk about the how, it's important to understand why we're doing this. A PWA is more reliable. While doing research on this topic, I came across a discussion on LinkedIn, and someone needed his Apex application to be usable on off-grid farms. Data entry had to be done on Apex, on a mobile device, on the farm. So a PWA right now is currently the only technology that would enable this kind of reliability. Another common use case is using our Apex application on the subway, for instance, where the network can go on and off. So even if we lose the signal for a minute or two, the PWA remains usable. Then a PWA is also faster than a traditional web app. By leveraging the cache API, a PWA can serve cached resources, like what I said about the Apex pages. And it can serve these resources to the user much faster than reaching to the server. A PWA is also more engaging. It will always be more convenient to reach for an icon on the home screen rather than a bookmark on the browser. By having an Apex application sitting explicitly on a mobile device home screen, the user engagement is significantly increased. But more importantly, users need to be reminded to go back again and again to their application to complete things. And email is not always ideal. Push notifications are simple reminders that can easily be dismissed, which makes them the perfect candidate to increase user engagement. As mentioned earlier, everything we'll be doing in this webinar is pure JavaScript and pure Apex. The only setup required for developing a PWA is about placing the static files at the right location on our server. I always encourage Apex developers to store the static files in the shared components because it makes deployments much easier, because the files are bundled with the application itself when it's exported. So when a file is being served from the shared components, it uses a public path. And that path is relative to your application URL. Here's an example of my development environment. This would be the URL of my app. And this would be how I reference a JavaScript file. So Apex resolves the reference to my JavaScript file to this. So basically, this is my domain. This is my schema. This is my application ID. This is the path to the root of my files in the shared components. And this is the location of my file. This methodology is good for most cases, but unfortunately, it will not satisfy a PWA requirements. In a PWA, some files need to be served from another location. Later in this webinar, we will discuss two files. Number one, manifest.json. This is what enables the installation of the Apex application on a device. And then serviceworker.js, which is the service worker, and it enables offline usage, push notifications, and much more. These two files are at the heart of a PWA, and they require a special treatment. They need to be at the root level of your Apex environment. So in my previous example, in my own environment, these files would be somewhere like here, localhost, with my port, and directly these two files. So the browser will handle these two files differently than regular JavaScript and JSON files. And if you don't do that, if you don't put them at the root, you will quickly realize that JavaScript errors are coming your way. All right, so how do we do that? There are many ways to set up an Apex environment, and each setup has a different root path. Let's use ORDS Standalone as an example. On your ORDS instance, locate your standalone.properties file. It should be located inside the config folder of your ORDS instance. And the content of this file should look like this. The value next to standalone.doc.root is the location where we need to put the service worker and the manifest.json. So we will define the content of those files shortly. But before we do, I have to pause here for a minute. A lot of the following code snippets will use a JavaScript technique and methodology that would be better served with a quick refresher. Okay, let's start with synchronous JavaScript. This should feel familiar to most Apex developers because PL SQL is mostly used this way. If we have 4 functions executing back-to-back, this is how it'll go. Function 1 starts and ends. Function 2 starts and ends. Function 3 starts and ends. Function 4 starts and ends. It's very, very simple. Synchronous JavaScript is easy to read and easy to write because executing sequentially from top to bottom is just more logical to the human eye. But unfortunately, synchronous JavaScript is slower. And when it executes the code, it also blocks the user interaction on the page. So, for instance, synchronous JavaScript process would prevent a user from scrolling or clicking anywhere on the page until the process is done or completed. It kind of feels like the page is hanging indefinitely. But the bottom line is synchronous coding is not the way to go in JavaScript. Asynchronous coding is the opposite ideology. Processes are no longer attached together in a specific order. You got to think of it as threads. Say we launch the same 4 processes again. They may not require the same amount of time to complete. So there is no particular order anymore. Here's an example. If you look at the console logs in that snippet, console log 2 is wrapped in an asynchronous block. If I read this from top to bottom, I would expect the outcome to be console log 1, 2, 3. But because apex.server.process, the block in the middle, is asynchronous, the result will most likely be 1, 3, 2. So it makes the code much less readable, and it's harder to write. But unfortunately, it's faster than synchronous coding, and efficiency always wins. So given the fact that we have to embrace asynchronous coding and methodology, I suggest we do it in a way that's enjoyable. JavaScript promises were created to help better asynchronous code. A promise is simply an object that returns asynchronous code. Let's take apex.server.process as an example, because it returns a promise. So I am declaring a function called something, and all it does is returning the result of an application process called something. Then we can invoke the function something, which will trigger the application process. And at this point, the promise is defined as pending because it means the the code hasn't finished executing yet. If the application process goes well, the promise becomes resolved, and then we can use the then keyword to indicate what to do next. If the process fails for any reason, then the promise becomes rejected. And this is how we are able to catch the errors. So it's a way to write a logical top-to-bottom asynchronous JavaScript. So promises are great for handling asynchronous coding, but one of the problems with them is that they're filled with syntax keywords, which pollutes the clarity of the code. We've seen that in the previous example. There were a lot of keywords. Async and await is a new methodology, and it introduces a cleaner way to deal with promises. So let's turn the previous example to use async and await instead. First, we indicate that the function something is asynchronous. We just add the async keyword before the function. Then what we want to do with an async function is to await it. This waits until the result is resolved before moving forward. The recommended approach for error handling is a simple try-catch. Very, very simple. So using async and await goes back to the root of writing simple synchronous code. But it also benefits from the performance efficiency from asynchronous and promises. So it is really the best of both worlds. Okay, let's finally dive on one of the most interesting progressive web app aspect, and that's how to install a web app on a phone. For those of you wondering, I am not talking about the kind of installation that means putting a URL shortcut on a home screen. I'm talking about having an actual button on your page that reads install this app. And then when you click on that button, it would prompt the installation process. And luckily for us, that also happens to be one of the easiest achievements. With every new aspect I introduce, I'll start with a quick demo, and then I'll proceed with the explanations. Okay, so here's my home screen. So first of all, let's look at the list of my applications. You'll notice that my last application is AZ Screen Recorder at the bottom. This is my last application. Now let's go to Chrome. I already have my Apex application open, and you can see this is an Apex application. This is universal theme. There's a menu. The only thing that's different is that I have install this app button in my navigation bar. So let's just go ahead and click on that. It prompts a modal window that says add to home screen. So I'll just click add, and automatically I get a notification that says adding this app to the home screen. So if I go back to my list of apps now, I see that my Apex application was added after AZ Screen Recorder. So now I have Apex PWA as my app. If I click on that, I open the same application, but the difference is there's no URL bar. It completely feels like a native application. So the app opens in full screen, and it is still the same application. All right. Trust me, installing an Apex application on a phone is easier than you would expect. So what we need is to create a special file called manifest.json. As mentioned before, the manifest.json file must be located at the root level of the Apex server. Here's an example of a typical manifest.json file here. It has to have a few properties. The first one being the short name, which is the name of your app on the home screen. Then there's the name, which is the full name of your application. And then you define a list of icons, which is useful for supporting most device sizes. And then there's the display property. The display property is a very important one. There are many options you can read about that you can set the display property to, but the most interesting one to me is the standalone value, which opens your application in full screen. Think about that for a second. You're running a web app in full screen without seeing the URL bar or anything. Just that itself is pretty amazing. Then there's the orientation property, which is what you would expect. You can lock your app to be in a certain orientation like portrait or landscape. And then there's background color and theme color, which are nice little add-ons to your manifest file, which allows you to pick the color of your phone's notification bar or the splash screen color. Okay, when the manifest.json file is completed and uploaded to the root of the Apex server, we still have to reference it in Apex. The following tip is kind of a hack, in the sense that in the shared components of Apex under user interface attributes, there's a section called favicon HTML. The fav icon is the little icon that you see on a browser tab right here. And the purpose of this field is to inject the icon into the head section of an HTML page, of an Apex page. It happens that our file, manifest.json, also needs to go in the head section of an HTML page. So what we'll do here is we'll leverage the fav icon field to reference our file, even if it's not an icon. So how do you get your app to install itself automatically? First, the browser has to recognize a few criteria. Number one, the app needs not to be installed already. So the app is not installed already. Number two, the user engagement. Your web app has to meet a user engagement heuristic. Currently, I think the user has to interact with the domain for at least 30 seconds. Number three, your app has to include an application manifest with the name property, icon property, and display property. Your application has to be served over HTTPS, which is required for a service worker anyways. And last but not least, your application has to serve a service worker with a fetch event, which we will explain a little bit later. Okay, here's the real deal. So to install an application on the home screen, what we want to do in a JavaScript file is declare a global variable to store the installation prompt. Then we will listen to the before install prompt event on the window element, which is triggered after user has met the installation criteria we've seen on the previous slide. So what we want to do with it is simply store the prompt request on our global variable, and then we will have a button in our app that triggers that request that we've saved. And then we can have additional code running if the user has accepted the installation or if the user has rejected the installation. So it's really just that. And when the user accepts, the application will be added to the phone home screen, and it will finally launch in full screen. Okay, I have been doing Apex since 2010, and I think it's safe to say that one of the most recurring feature requests would be offline usage. Let's make something very clear. Apex lives in the database, and it's not recommended to embed an Oracle database on a phone right now. So the Apex server, which is the Oracle database, is still remote. So when we are offline, we cannot reach that remote server, right? It truly leaves us with only one option, which is caching the application. As far as a PWA is concerned, what we want to cache is something called the app shell. The app shell constitutes all the necessary resources for navigating through an Apex application without stumbling on a 404 error. From an Apex perspective, that means all the pages, all the static files from Apex, and all the custom static files from your app, your own JavaScript and CSS. At the time I'm conducting this webinar, some paradigms of Apex will not work well offline, like the interactive report or the interactive grid. Those components rely heavily on querying the database with AJAX calls, like the search feature of interactive grid. So as soon as you do a search in the interactive grid, it queries the database. So if you're offline, that won't work properly. To control the resource caching, we'll have to look at the service workers and the cache API, both of which are native to web browsers and constitutes the pillars of Apex offline usage. Okay, here's a demo of a regular Apex application trying to go offline. So this is coming from apex.oracle.com. It's the standard universal theme demo application. So I'm online right now, and if I navigate through the tabs of this application, everything works well. I can navigate back and forth, all good. Now, if I go offline though, I'll just turn off my Wi-Fi. And I'll try doing the same. I'll go back to the icons. Now I see the application crashes automatically. So if I go back and I reload the page, it also crashes. So there's no way of accessing the Apex application unless I turn my Wi-Fi back on and refresh the page. So obviously this application is totally not offline ready. Now let's do the same exercise on a PWA application. So this is my PWA application, still universal theme. What I'm going to do now is turn off my Wi-Fi again. And notice that I have two tabs. The first one is home page. The second one is other page. So first of all, I get a nice indicator that I have lost connection. So at least I know that I'm offline. And I will still try and navigate to the other page, and it still works because the page has been cached. I can also go back and forth between all of my pages. Now, if I activate my Wi-Fi again and retrieve connectivity, I get a nice notification that mentions I am back online. So that application is obviously usable on offline. Okay, what happens behind the scenes? Well, what exactly is a service worker? At a very high level, a service worker is a JavaScript process that spawns within your application, but it runs completely in the background of your system, and it continues to live there even if you've closed your application or turned off your phone. So the first thing I want to do is to register a service worker in my application. That will allow to make the connection between our application JavaScript and the service worker. Okay, what do we do here? First of all, we want to verify if the browser actually supports service worker. And then we'll register the service worker by referencing a file. And I'll come back to this later. Then the service worker is registered successfully, or if it failed, we'll know here using a catch function. And before I move on, I really want to emphasize on the reference to this sw.js file here. sw.js is the service worker file, and it has to be located on the root of your Apex server. Now let's move to the service worker file. Let's start with a very simple one. All it does is listening to the activate event, which happens on every page load to activate the service worker on the page. This makes the link between the service worker and the Apex application. To verify that our service worker has been activated properly, we'll check in our browser developer tools. So number one, the service worker is located in the application tab of the developer tool, and there's a section called service worker section. That is number two. Number three, we can see that the status shows that our service worker has been activated and is running. Number four, our console log statement from the previous slide now confirms that it ran successfully. So before showing how the service worker uses the cache, let's define the cache. Caching an application is about storing resources locally. When a resource is cached, could be HTML, CSS, or JavaScript, the browser no longer requires access to the internet to serve these resources. So to do this, we'll leverage the Cache API, which is a native API for browsers. Again, no external library. One obvious advantage of caching resources is that they can be served faster than regular server resources. So not only a service worker allows offline usage, but it also increases the performance of your application. Now, there are two types of caching, static and dynamic. Let's review both and highlight the differences. So at this time, our service worker is running, but it doesn't really do anything. From an Apex perspective, static caching means the Apex pages. When we install a progressive web app onto a mobile device, we want to fetch all the pages and the associated resources and store them locally. This is the app shell, right? So we will leverage the install event, which runs only on the first page load ever, only when you install the app. So what we're doing there is we're opening a cache named cache static. This could be anything. I just named it cache static. And then we're defining an array of Apex pages because we want to store them in the cache. using the add all method. So from here already, all of our Apex pages should be cached properly. And before going into dynamic caching, let's have a look at the fetch event, which is pretty much the most interesting part of a service worker. The fetch event is triggered whenever a resource is coming through to your browser. Any file, any data, anything. The service worker stores the incoming request in a variable. If the fetch succeeds, if the resource succeeds to load, then we're just simply returning that request back to the browser. So the user navigating your application doesn't see a thing. All we're doing, all the service worker is doing here is intercepting the request and doing nothing with it. Now let's extrapolate this methodology. The idea is that we want to leverage the fetch event to create a dynamic cache for any resources that will be coming through. Dynamic caching is pretty much the center of the bullseye for the service worker. And I'll explain why. Again, we intercept all incoming resources to the browser with the fetch event. But now what we want to do is check and verify if the incoming resource exists in the cache already. We're checking if it exists. If it exists, then we simply want to serve the resource directly from the cache. We don't need to reach the server, just serve it from the cache. If there is no match in the cache, then we have to fetch the resource from the server. At the same time, when we're getting the resource from the server, we also want to open a new cache, a cache that I will call the dynamic cache, and we want to put that new resource from the server in the cache. And finally, we can serve the resource to the user. So again, user doesn't see a thing. We intercepted resource. We either served the cached resource or the server resource. Okay, so now our application still displays something when we're offline. But as I said before, in the context of an Apex application, I would argue that it's not useful enough if we cannot save anything. So because we're offline and therefore cannot reach the server, the idea is to store the pending requests in a queue of pending requests. And then we will be using the Sync API because we want our Apex application to execute the queue when we get back online. Execute the queue of pending resources. Okay, so back to my PWA demo application. Let's talk about the content of this application. What we have here is a form where we can enter our name and a comment, and it just has a report at the bottom of that. So I'm online right now, and I'll fill my name, and I'll put in a comment, and I will hit send. So naturally, I inserted this comment in a table, and I refreshed the report, so it all looks good. And there's also a small indicator that says that the message has been sent. It's saved. Perfect. Now let's go offline. Turn my Wi-Fi off. I still get the little nice indicator that says I've lost connection. And I'll try to put another comment now. I'm offline. I cannot reach the server. So let's hit send again. Now the report refreshes, but my comment cannot be saved. So instead of Seeing the sent indicator, I see it's waiting on connection, but it's still there. So usually what happens when you add a comment or send a message, you turn off your phone, and then eventually you'll get connectivity back. So if I turn my Wi-Fi back on, boom, automatically my message has been sent. So this is very useful to send data or form data when you're offline, and then you don't worry about it in the future. So let's start with something really simple. How do we know if a user has lost connection, and how do we know if he's regained connection? The solution is to listen to the online event and the offline event, which are triggered on the window element. When the online event fires, what we could do is display a nice little success message indicating that the connection is back, just like we showed on the demo. When the offline event fires, we could display a warning message indicating that the connection is lost. So now that we know exactly when a user goes online or offline, I think it would also be good to know the connection status at any given time. So for that, we can use the navigator.online property. And in the case where the user is offline at a given point in time, what we want to do is storing a request in the cache, or more specifically in the IndexedDB for later usage. So what is IndexedDB actually? IndexedDB is a browser API for client-side storage. It can store JSON data, blobs, or files, or any format type, really. It has the ability to query data, like SQL does, but more importantly, it works with client-side JavaScript and with Service Worker. So it's a very efficient way to communicate between the app and the Service Worker. So here are some tips and things we can do with IndexedDB. First is we can give a name to our database using the config method. And then we can add things to our database using the setItem method. We can loop through our database and read data using the iterate method. And then we can finally clear the database using the clear method. It's a very straightforward API, actually. So now that we've put all the pieces, actually now we have to put all the pieces together, and this is where it gets interesting. There is a very important shift in the paradigms of Apex development here that we have to do. In order to resubmit data to the server when connectivity comes back, all backend processes must be exposed as web services. So when the user is offline, a reference to a web service can simply be stored in the IndexedDB, which will be invoked by the service worker later on when we get connectivity back. Let's look at this code. Let's just say that our app has a button somewhere that calls this function something. And immediately what I want to do is validate. I want to know if the user is actually online or offline. If the user is online, then let's just execute the code normally directly to the server, no problem. But if the user is offline, then what we want to do is store a new pending task to the IndexedDB. exactly what we want to store is a REST endpoint to the desired process to be executed, and also the data that we want to send to the REST endpoint. After the data is stored, we will register a sync event. That last part is very important. I'll come back to that. Just remember that I registered a sync event. Now let's go back to our service worker. How do we handle requests when we are back online? So we're offshoring tasks to the service worker, right? And remember that the service worker works even if you've closed your app. So whenever the connection comes back, the service worker will trigger a sync event. It will trigger a sync event. And on the last slide, we triggered an event called sync something. So here we are validating the kind of sync event this is. Then we can simply iterate in all the pending tasks that were done when we were offline. And finally, we can re-invoke the web service, just like we would when we're online. So our progressive web app is shaping up pretty well, but we're still missing one critical feature. And at this point, I would argue that we're probably sick and tired of push notifications coming from all of our apps. But at the same time, coming from an Apex application, somehow it still feels fresh and innovative. So let's look at this example. On the left-hand side of the screen, I have a mirror of my mobile device. And on the right, we see SQL Developer with a block of PL SQL code. So what we'll be doing is I have my application installed on the mobile device, and we'll use SQL Developer to trigger the push notifications. So just to validate, this is an Apex application. I opened it, it opens full screen, and I'm closing it. And running the PL SQL code in SQL Developer. And I ran it 3 times, and it's sending the push notification instantaneously. So this is destined to a particular user, but again, it could be sent to a group of users or literally all users of your app. So very useful to increase user engagement. I said going full PWA doesn't require any third-party service, but for push notifications, we actually do. Firebase is a service from Google. Firebase is also the central point from where notifications are sent to the mobile devices. And Firebase happens to be the solution that Oracle itself recommends for sending push notifications in general. Because we don't really want to create an app that spams everybody with push notifications, I think the first logical thing to do would be to ask permissions to send notifications. The way to do this would be by, first of all, prompting the notification request to the user. And then we want to subscribe to the notification. So the way to do that is by telling Firebase, our third-party service, that this current device is now subscribed to notifications. And then we can even send a first notification to test the feature. And remember, this is all native APIs. Once the user has registered to push notifications, we now want to be able to send notifications to them. From an Oracle development perspective, it would make a lot of sense to invoke push notifications from PL SQL. So this screenshot shows a web service call to Firebase, which triggers the notifications to all registered users of our app. Now, extrapolate this methodology. You can use this in any part of your backend code, whether it's in a trigger or in a package, or even if in your own Apex application, anywhere, right? It's just 10 lines of PL SQL. So we've sent a notification request from SQL Developer. The request has been funneled to Firebase, and now it's being sent back to the service worker. At the risk of repeating myself, the service worker is a JavaScript file that runs in the background. So it is the perfect candidate to listen for these incoming push notifications and actually do something about it. Back to our service worker file now, we will add a new event, which is the push event. The push event receives an object that contains the content of the notification. And then all we have to do is show the notification using a native API. So just to make it clearer, if I put the two last slides side by side, on the left, we have the SQL dev code. We're invoking a REST call to Firebase with an object containing the title and the body of the notification. Then this is being parsed by the service worker and displayed to the user. So after we've received a notification, we might want to handle the actions that a user makes on them. So for instance, the service worker allows to handle what to do when you click on a notification. Perhaps you want to open your application back or log something, completely up to you. Or maybe you want to do something when the user has closed or dismissed the notification. Okay, let's stop there for today. I hope progressive web apps piqued your interest and that you're able to see why it matters. A fight is coming, and progressive web apps actually have a lot to offer. I want to leave you with a few development tips. First of all, I personally find Chrome to be the best browser for developing a PWA because of its developer tools features. Chrome's developer tools allows to audit your application and give a score to PWA features. At any point in your development, you can just go to audits and click on perform an audit. You'll get a page resembling this. This audit is checking for progressive web app features. It gives you an idea of the coverage and where your app should improve, right? So for some reason, my app was deemed too slow on the 3G network. So maybe I should work on the performance of my application. This tool actually gives you a score to other areas of web development, such as accessibility, best practices, SEO, and other areas. But for the purpose of today's webinar, we really want to focus on the progressive web app section. Tip number 2, and the last one, as you are developing an Apex application, which is offline ready, a common problem you will encounter is that your new JavaScript and CSS, the code that you are pushing to your development environment, is not showing up. And that's normal because the service worker sees that you're offline and it tries to serve you the old JavaScript and CSS. So to fix this, you might want to disable the cache in your browser, because otherwise you will never get to see your changes as the browser tries to serve you old files. So in reality, caching only makes sense for production environments. Also, if you want to simulate going online and offline and test your cache, you can check the box just here or simply turn off your Wi-Fi. Final thoughts. So is a PWA just another gimmick? I think not. I think it's really just an abstract term to describe a few concepts. So you have to look at PWA like building blocks. You start with one block and you progressively add more blocks over time. An easy one to start with would be making your app installable on the home screen. It's a baby step towards a big PWA, but it's a very important step. And you don't actually have to implement all PWA features. So I think there's no escaping PWA in the future. Customers are inevitably going to start asking for it as browser support are closing the gaps between native apps and web apps. So we better be ready as a community to offer the best applications available on the market. And I think Apex is a pretty damn good candidate for that. So for clarity purposes, some of the code snippets in the slides were simplified. You can get the complete code and instructions and comments on GitHub here. So please give it a spin, and thank you for attending. If you have any questions, I'll remain available until the end of the session. Thank you.
Thank you very much, Vincent. Thank you for that excellent presentation on emergent technology PWA. We have a few questions, and I'll put them to you. My first question is, my company only allows IE11. Will PWA work for me? My understanding is that PWA requires the latest browsers. IE11 may not fully support PWA.
And that is 100% true. IE11 might not support all features, so IE11 is not the best candidate for a PWA. Definitely not. All major browsers are all support PWA at the moment.
Okay. Next question is, can't I put a web app icon on my phone too? No need for PWA for that.
It's not the same thing, because putting an icon on your home screen using traditional methods is really just a shortcut to your application. So it opens the browser, you see all the URL bar and everything. So it is not the same thing as installing the app and caching everything on the phone. You don't get the full app experience by just putting a bookmark on your home screen.
Okay. Next question is, why is Vince saying we should server.js from the DB? I thought it would be best to have it on the web server.
That is really more of a personal preference for me. I've been bundling all my JS and CSS files in the Apex shared components because it makes deployments much easier, although serving them on the web server is perfectly fine as well.
Next question is, have I understood this correctly, that if we use Apache or Nginx as reverse proxy in front of Tomcat with ORDS, we need to put our static files to the doc-root directory of it? Actually, the doc-root directory of the corresponding virtual host.
And the answer is yes, that is correct.
All right. Next question. If I include this manifest.json, can I still use the app on a 27-inch monitor?
Not only you can use it on a 27-inch monitor, you can use it on a TV or any screen size. It doesn't matter.
Okay. Does all the stuff you demonstrated on Android also work the same on iOS?
That's a great question. And the answer is there are slight differences, but the market is moving toward establishing standards for PWA. I think right now there are still a few differences, but most of the features are mostly implemented on Android and iOS.
Okay. Next question. Not sure if I got this right, that PWA are not working offline with interactive grid and interactive reports, or is there a workaround with this cache API?
There are no workarounds for interactive grid and interactive report. The only thing you could do is have these components available when you're online and maybe disable them when you're offline or hide them, but there are currently no ways to make them work offline. That's a drawback.
But something that may be corrected in the future, you think, or?
It could, and I've heard discussions of implementing PWA features directly within the interactive grid. So possibly one day, yes.
Great. And for our last question today, so I see you mentioned browser compatibility when you explained Service Worker. Which browser is that? Is it the browser where you installed the app originally? So does the app icon still invoke that browser behind the scenes, even if it appears to be a typical phone app?
So there are multiple questions in there. The app does invoke the browser in the background behind the scenes, but it hides everything else. So the URL bar or any browser features, it allows your app to run as if it was a native app visually. But yes, the browser is still rendering the HTML and the JavaScript and everything else. Which browser are supported? All major browsers, literally all of them.
Great. And that concludes the questions for today. And thank you to everyone who's watching. And we invite you to continue to follow InSum and our webinars. And if you want to know our latest schedule, please go to insum.ca/resources/webinars to learn about the scheduled next webinars. Thank you very much, Vincent, for this very informative presentation, and hope to see everyone soon. Thank you very much.
Thank you.